we don't want it's not.
Alright, this is kind of a continuation on the inverse idea that we just got done talking about. One thing I did forget to put in that first video was that, again, if the determinant of a matrix is 0, the inverse is not possible, because 1 divided by 0 is undefined. So if you ever get 0 for your determinant, when you do AD minus BC, know that an inverse does not exist. Okay? Alright, I'm going to do some quick matrix multiplication here for you. Alright? I'm going to go across the row down the column. 3 plus 0 is 3. 0 plus 6 is 6. That would be the answer to this one. Here, 2 plus 0 is 2. Negative 3 plus 0 is negative 3. 0 plus 4 is 4. 0 plus 7 is 7. Okay? Some real quick matrix multiplication. Tell me what you see. They're the same. So when I took this matrix times 3, 6, it equaled itself. When I took this matrix times this one, it again equaled itself. Okay? Notice these two matrices are the same, right? Okay? This matrix right here is essentially like what number when you think of multiplying numbers? 1. When you take something times 1, you get itself, right? 1 times something is that something. 1 times that something is that something. Okay? This matrix here is like the number 1. It's called the identity matrix. Okay? It's the 2 by 2 identity matrix. Okay? Again, when we're working by hand, we'll be working with 2 by 2s. Okay? And this will be your 2 by 2 identity matrix. It has 1s going out down this diagonal from top left to bottom right, and all other terms are 0. A 3 by 3 identity matrix, again, has 1s going down this diagonal and 0s everywhere else. Okay? They act just like the number 1 does in multiplication. If you take an identity matrix times another matrix, it will just equal itself. This acts like the number 1. Okay? That's called an identity matrix. Now, I want to go back a little bit. When I take a number times its multiplicative inverse, I get the number 1, right?
Yep. Yeah.
So guess what you're going to get when you take a matrix times its inverse?
The identity matrix.
The identity matrix. It would be a way to check your answer as being correct. I could take this matrix, multiply it by this one, and it will equal the identity matrix if you have done it correctly.
Interesting.
Because anything times its inverse is 1, right? With numbers, 7 times 1/7 is 1. 2/3 times 3/2 is 1. A matrix times its inverse would be like the number 1, which I said is the identity matrix. So it would be a way to check to make sure that you did your inverse correctly. Alright? Do you want me to see us do the multiplication on this?
No, I'm good.
You guys are good? Okay. Alright, so if I take this matrix times this one, now this is also one that would actually, it would work the other way too. Okay, this one would work. Most of the time it doesn't, but this one it would. Either way, when I multiply these two together, I will get that identity matrix. If I take matrix A times the inverse of A, I will get that 1, 0, 0, 1 matrix. I will get the identity. Okay? How do we feel about that concept?
Pretty good.
Pretty good with it?
Much better than
Okay? Alright. Let's see, so I talked about identity, I talked about inverses, we found the inverses. Okay?
What is Cramer's rule?
I'm doing something different. I just like the equation, so. Alright. Let's multiply these matrices together. So, I'm going to start with this. This is called a matrix equation. And we're going to solve this matrix equation. We're going to figure out what x and y are. Okay? I'm going to show you how this relates. Can you get you started? Go and multiply these two matrices together. I'm going to go across the row, down the column, right? So 2x minus 3y has to equal 23. You with me? 2x minus 3y, we know now that equals 23. And then 4x plus 1y has to equal 25. When I ask you to solve this, I'm really just asking you to solve this. You've done this before. That's a line, that's a line. How do I solve a system of equations? Graph it, see where they meet. Use substitution, use elimination, whatever you want to use. Okay? For a simple system of equations like this, you would probably use one of those methods: graphing, substitution, or elimination. I'm going to teach you how to do it with matrices. You're like, well, why? Okay? Well, I agree. For a simple one like this, you probably would just use graphing, substitution, or elimination. Let's say all of a sudden our system of equations now had 4 equations with 4 different variables in it. You don't want to use substitution or elimination. It will take 2 sheets of paper to get that done probably. Okay, so that's why I'm going to teach you how to do it with matrices, because I think you'll like it. It's pretty slick. Okay? So, alright, everybody understands that this is the same thing as this. Okay? This is called your matrix equation. This is just your basic system of equations. They say the exact same thing. So, I'm going to solve it using matrices right now, because you guys know how to solve it using graphing, substitution, and elimination. Okay? I'm going to call this matrix A. I'm going to call this matrix X. And I'm going to call this matrix B, just like we did earlier in class, right? So really I have matrix A times matrix X, and that equals matrix B, correct? My goal is to solve for matrix X. How am I going to solve for matrix X? What do I need to do to get X by itself? Multiply by A inverse. So A inverse times A times X equals A inverse times B, or in other words, is x will equal A inverse times B, right?
Yep.
So all you need to do to solve this is take the inverse of A, because this was A, right? Take the inverse of A times B, and you will have your answer for x and y.
Oh.
Okay? Matrix X, which is this matrix, XY, will equal whatever A inverse is times B. Okay? So A inverse (2 minus -12 is 14, right? A and D do what? Switch spots. B and C
Change signs.
change signs. So 3 up there, -4. So that'll be 1/14, 3/14, -2/7, and 1/7. So there is A inverse. I need to take A inverse and multiply it by matrix B, which is 23 over 25. Okay? You guys are going to probably use a calculator to help you. 23/14 plus 75/14. Everybody see that? 23/14 plus 75/14 would be 98/14,
7.
just 7. -46/7 plus 25/7 is -21/7 or -3. There are your answers. X is 7, Y is -3.
Can we do that like X and P?
You could, if I were asking you to write it out, I would probably ask you to write it like this. XY equals 7, -3. Okay? You may want a graphing calculator to follow along with. I'll show you how easy this is on a graphing calculator. Okay. I believe over here on your x to the -1 key right above it, you should see the word matrix.
Yep.
I've seen it.
Yeah, good luck, Julia.
This one says math.
Maybe.
Wow. This looks like. Oh. Oh, it's not. Oh.
So a screen like this will show up. You may have different numbers there, but a screen similar to this will show up where it says names, math, edit. Okay? Let's say I want to do the problem that we just did.
Oh no.
So this was our matrix A, correct?
Yeah.
And this was our matrix B. I'm going to create these two matrices on my graphing calculator. So I need to go over to Edit.
Oh,
Oh,
that makes sense.
I need to go over to Edit. Press Enter.
okay, I'm having problems.
I want a 2 by 2.
I messed up. I messed up. I'm hitting too many buttons.
This is crazy.
Do I need to stop?
No, you're good. It's just
No,
this
I
is one
just-
of mine right now.
It's
Okay.
just, it's doing
What
it.
were my values? Can anybody help me out so I don't have to change screens? 2. Go across.
-3.
-3. 4 and 1.
Yeah. No, please just work with me here.
Okay. So I'm going to tell my calculator, I want you to create a matrix A. It's a 2 by 2 matrix. The numbers in that matrix are 2, -3, 4, and 1. So I created matrix A.
Okay.
I need to create matrix B, so I'm going to go back to matrix. So second, x to the -1. I'm going to go over to edit again. Please don't edit matrix A. You have it how you want it. Go down to matrix B, all right? Otherwise you'll be mad at yourself like, well, where did A go? Well, you changed it. That's where it went.
I
Okay?
don't have it how I want it yet.
So now I'm going to edit matrix B. It's just a 2 by 1. Those values were 20,
3 over 25.
23 and was the first one, and 25 was the second one.
Yep.
Okay, so now I've created matrix B. To get my answer, remember, I took the inverse of A times matrix B, right?
Mine just keeps taking me.
Here's where life is easy. Okay. Go back to your calculation screen where you do all your add, subtract, multiply, divide. Okay, so quit out of the matrix. Go to second matrix again. I need to take A inverse times B. So while I'm on names here, I'm going to select A. Press enter. I want to do the inverse of that. Well, remember, inverse is like raising something to the -1 power, so I'm going to hit my -1 key.
How do you just, I need you to go back. I don't know what just happened.
And then I'm going to go times. I need to enter matrix B here, so I'm going to go to matrix. And under names, I'm going to select matrix B here to get matrix B to show up on my calculation screen.
Cool.
And voila.
Okay, hold up.
Okay?
Amazing.
Alright, there's going to be lots of questions. I'm going to stop the video.